This is Vishesh Maan, student of MTech in Department of Physics IIT Roorkee. This PPT is to be submitted to Dr. Mayank Goswami and he is teaching us numerical analysis and programming in this semester. My PPT topic is numerical integration techniques using MATLAB. Here we will demonstrate how to evaluate a function's integral numerically using MATLAB. We can approximate the value of integral whether or not the functional expression is known using numerical techniques. So our first question that arises in our mind is what is integral and integration. The term integral was first introduced by mathematician J. Bernoulli in 1690, and you can see that there is the integral term used first time by J. Bernoulli in his Latin language text. So if we want to find the integral of real valued function fx with respect to variable x from interval a to b, then we can write it in the form of as it is mentioned here. So the integral sign represents integration. So why do we need coding for it? Actually, in real life problems, the function fx is only available in the tabulated form with values known only at certain discrete points. So MATLAB along with numerical techniques handle them elegantly. So instead of doing manually, we can use coding for it. And very often the function that we are going to integrate is too complex to handle manually. So using the software packages and coding, we can do the integration in very minor time, and we can also reproduce the results that are already given in the literature in quick manner. So what are the types of integrals? Firstly, definite integrals. There are upper and lower limits are defined. Sometimes they are also known as bound limit integrals. And second one is indefinite integrals. Their upper and lower limits are not defined. So firstly we will discuss how to evaluate the indefinite integrals using inbuilt functions of MATLAB. Now we will firstly discuss required inbuilt functions. Firstly we will understand how to define an anonymous function. An anonymous function is associated with a variable whose data type is function handle, and anonymous functions can accept multiple inputs and return one output. For example, if you want to create an anonymous function that finds the square of a number which is fx is equal to x square, then in mathematical, or you can say MATLAB coding language, we will write it f is equal to @x, where @x represents that x is a variable in the function fx and x to the power 2. So, and then the function for integration, that is int. An int function computes the indefinite integral of expression with respect to the scalar variable given in the arguments of the function int. First argument, that is expr, is the expression for which we want to find out the integral, and second argument for the int function is for the variable, and integral is computed with respect to it. So we will discuss for our first example. Now the question is, find the indefinite integral for the given three functions using the inbuilt function in MATLAB and display the result in the end. And functions are fx, gy and hz. Now, so first part of the code is, firstly we will define anonymous functions for each fx, gy and hz. For fx, we will define function anonymous function, and then for gy, then for hz, and then creating a symbolic function for xyz by using syms. Now in the second part of the code, we will use the int function to do for the integration. So for fx we will define a variable p, and for gy we will define the variable q, and for hz we will define the variable r. Now to display the results of the integration, we will use the display function for displaying the end results in the command window. Now for display integration of fx, we will display p, and then integration of gy, then integration of hz. So here are the required results of the integration for the given functions. Integration of fx is this, integration of gy is this, and the integration of hz is this. Now this is the output of the code which is which is shown in the command window. So basically we will move on to the definite integrals. Definite integrals are the extension after indefinite integrals. Definite integrals have limits a to b. So here we will discuss two numerical methods for finding definite integrals. First one is trapezoidal method and second one is Simpson's one-third method. Firstly, we will discuss the trapezoidal method. In trapezoidal method, the main idea is to accept the region under the graph of the given function to be trapezoid rather than rectangular shape, and then calculating its area. And the formula used in trapezoidal method is as follows. So if you want to find the integration of function fx from a to b with respect to x variable, then the formula used is written here, where h is b minus a divided by n, where n is the number of subintervals. So without going into the much detail in theory, so we will discuss example. The question is find the definite integral for the given function using the trapezoidal method without using the inbuilt function in MATLAB and display the result in the end. So the function given here is fx is equal to 1 by x square plus 1, where lower limit is 0, upper limit 1 and number of subintervals are 10. Now first part of the code is written here, where firstly we will define lower limit which is 0 and then upper limit which is b is equal to 1, and then the number of segments, or you can say number of subintervals, is equal to 10. And then defining the anonymous function for fx is f at the rate x 1 by x square plus 1. Now symbolic scalar variable is defined using syms x, because there is only one variable in our function x. Now in second part of the code we will define h, which is the segment size, and then defining the x variable which stores the summation of first and last segment, and then using the for loop we will store the rest terms in R, and finally using the trapezoidal rule formula we will store the values in I, which is the integration result of the given function, and then for display we will use the disp function and for displaying the output. Now the end result, or you can say the output of the code, is written here. Integration result of the given function is 0.7850. Required result of the integration for the given function is mentioned here. Now the code we created for the trapezoidal method is a standard code, you can say. If you want to find integration of another function, you can say fx is equal to x square or fx is equal to x cube, then you can use this code as a standard code by changing the values of a, b and n. Now we will move on to the Simpson's one-third method. Here we evaluate the definite integration using this technique by successive segments of the curve. It helps us to make the approximations more precise. So Simpson's one-third method is more accurate and precise from the method trapezoidal rule. So in trapezoidal rule we use the trapezoidal segments. Here we will use the straight line segments instead of parabolic arcs. Formula used is written here, where if we want to find the integration of function fx with respect to x variable from a to b, then this formula is used, which is Simpson's one-third method, where h is equal to b minus a divided by n, and n is the number of subintervals. We should note that here n must be even. In Simpson's one-third method, you should note that n must be even here. So we will discuss example based on it, and problem is find the definite integral for the given function using Simpson's one-third method in MATLAB and display the result in the end without using the inbuilt functions. So function we take fx is equal to cos x multiplied by log x multiplied by sin y, where lower limit is 1, upper limit is 5 and number of subintervals are 16. You can observe that here we take the subintervals even. Now first part of the code for the Simpson's one-third method is, firstly we will define the lower limit and then upper limit and number of segments, and then declaring the function, or you can say defining the anonymous function for fx is f at the rate x cos x multiplied by log x multiplied by sin x. Now creating a symbolic scalar variable x and then defining the segment size h is equal to b minus a divided by n, where n is the number of subintervals, or you can say number of segments that we divide the area under the fx in how many number of subintervals, or you can say number of segments. So x stores the summation first and last segment fa plus fb. Now in second part of the code, we will define odd and even variables to store summation of odd and even terms. And using the for loop, we will fill odd and even variables for the desired results. Now finally, using the Simpson's one-third formula, we will store the values in I and finally displaying the result using the dis function. So now we will move to the final result, or you can say required result of the integration for the given function. Now the output of the code is as follows. Approximation of the above integral is 0.2207. And now the code that we have written for the Simpson one-third formula is standard code. If you want to find the integral of any other function using Simpson one-third formula, you can use my code, and because you have to just change a value, b value and n value. A is the lower limit and b is the upper limit of the integration, and n is the number of subintervals that you take to solve the integral. Now n must be even in Simpson's one-third formula. This would be noted. So here are the references that I refer to make this PPT, or you can say understand this topic. Here is the research article Numerical Integration, which is printed in Encyclopedia of Biostatistics by Smith Jake in 1998. And here is the online site Integration MATLAB and Simulink MathWorks India. And other sources numerical integration in MATLAB step-by-step method to numerically solve the problems. And integration using MATLAB by Stakes Overflow. So thanks for your concentration and listening my PPT. Thank you.